Okay, so we are going to look a little bit at how we can construct some of these two-dimensional surfaces from some flat shapes by associating or gluing together edges and vertices. So in both of these examples, edge A and edge A at the top and bottom will become the same edge A when they're glued together. Edge B will be glued to edge B, and any vertices that have the same label will also be glued together. So at the top, point P and Q are different vertices, but at the bottom, point P and point P are the same point, and so they will be glued together. So the big difference between these two examples, besides the labels on the vertices, is how the edges are oriented. So in the top example, we're going to orient both A edges like this, so that when we glue those two edges together, what we end up with is a sphere. So this thing zips to a sphere. But in the bottom example, we're going to orient these edges opposite. And what happens is that first we will glue point P to itself, and then as we start to zip those two B edges together, what happens is that this surface ends up having to intersect itself in order to zip closed. And whenever that happens, what we have is considered a non-orientable surface. And this particular one we call the projective plane. Projective plane. And I'm using this word zip for a really good example of how this zipping works. I'm going to link to a paper on John Conway's zip proof of the classification theorem. Now, a lot of that paper is going to be a little bit advanced at this point, but the beginning and some of the examples, especially the illustrations, will be really helpful to illustrate what's going on here. So there's our kind of first two simple examples.